Well, Mr. Gage allowed us to learn an awful lot about the brain. We learned that the brain is made up of localized functions and that the brain is made up of a vital force. And on this slide, we can see all the different areas where they are located and what they are responsible for. Hence, the movement, sensation, judgment area, vision, coordination, reward, memory, and pain. The second slide, what I'm trying to do here in the next section of this presentation is that I'm just going to show you that there's major areas in the brain that is included in the addiction. And you will be hearing a lot of these terms throughout this presentation and also the videos that I submitted within this presentation. So don't get hung up on the terminology at this point. I just want you to start to become familiar with these names, such as the nucleus accumbens, the ventral tegmental area, VTA, and the prefrontal lobe. So these are basically the areas where addiction is affected. And here's another slide that shows the substances that do affect in what areas of the brain. They call it the dopamine pathway, and one of the neurotransmitters that are affected by addiction is dopamine, and it's the primary neurotransmitter. And you will see other ways that we can increase that dopamine. And my computer is not letting us change. Let's see. There we go. The brain is the organ which controls all processes within the body. So one of the particular areas that addiction is affected is through the cortex. This is the outer part of the brain that is responsible for all executive functions. And through the video of Mr. Gage is that we recognize that this was part of the area where the spear went through his skull and brain. The cortex helps us to reason, think about consequences, make rational choices, helps us to be future-oriented, and helps us to problem solve. So this is the last part of the brain that is fully developed. It takes about 25 years for the brain to fully develop. Hence, adolescents, they have difficulty making executive functions, thinking about the consequences because this area has not been fully developed for them. The prefrontal lobe is the primary area of where this is affected of Mr. Gage. And as we saw, it was damaged and it created disinhibited behavior. He had poor self-monitoring, failure to make access to consequences of one's actions. The other part of the area that is affected by addiction is the limbic system, which is the mid area of the brain. This part of the brain is known as the emotional brain. It's responsible for feelings, all emotions, helps to regulate the needs of the body and to keep those needs met. It lets us know when we're hungry or thirsty, and it is the first responder to let us know when danger is near, responsible for the experience of all pleasure. So when the danger is near, this is the area of the fight or flight area. The VTA, which is the ventral tegmental area, it is where it sends the signal to release the dopamine to the nucleus accumbens, and then through the process, the reuptake ends the signal. Also, it is involved in known as the anticipatory signal. If this anticipation can't be fulfilled, it might be replaced with another behavior. It is believed that many forms of addiction begins here. So as you can see in the illustration, here's the VTA, the nucleus accumbens, and then the prefrontal cortex. Again, all in this area where addiction starts and is affected. The nucleus accumbens releases the dopamine in this area, seems to be related to the experience of intense pleasure. So here's different ways that dopamine can be increased, is that they have research that movement, hence exercise, motivation, addiction, and reward and well-being. So they're saying that through evidence-based research has seen that dopamine is increased through the process of exercise, through meditation, through mindfulness, through new and novel things, experiences, and socialization. I'm going to stop the slides at this point, and there will be 2 questions that you will need to answer, and then we'll move on.